In classical mechanics, analytical dynamics, or more briefly dynamics, is concerned about the relationship between motion of bodies and its causes, namely the forces acting on the bodies and the properties of the bodies. The foundation of modern-day dynamics is Newtonian mechanics and its reformulation as Lagrangian mechanics and Hamiltonian mechanics. History. The field has a long and important history, as remarked by Hamilton. The theoretical development of the laws of motion of bodies is a problem of such interest and importance that it has engaged the attention of all the eminent mathematicians since the invention of the dynamics as a mathematical science by Galileo, and especially since the wonderful extension which was given to that science by Newton. William Rowan Hamilton, 1834. Some authors and Greenwood include special relativity within classical dynamics, relationship to statics, kinetics, and kinematics. Historically, there were three branches of classical mechanics: statics, kinetics, and kinematics. These three subjects have been connected to dynamics in several ways. One approach combined statics and kinetics under the name dynamics, which became the branch dealing with determination of the motion of bodies resulting from the action of specified forces. Another approach separated statics and combined kinetics and kinematics under the rubric dynamics. This approach is common in engineering books on mechanics, and is still in widespread use among mechanicians. Fundamental importance in engineering, diminishing emphasis in physics today. Dynamics and kinematics continue to be considered the two pillars of classical mechanics. Dynamics is still included in mechanical, aerospace, and other engineering curricula because of its importance in machine design, the design of land, sea, air and space vehicles and other applications. However, few modern physicists concern themselves with an independent treatment of dynamics, or kinematics, never mind statics, or kinetics. Instead, the entire undifferentiated subject is referred to as classical mechanics. In fact, many undergraduate and graduate textbooks since mid-20th century on classical mechanics lack chapters titled dynamics or kinematics in these books. Although the word dynamics is used when acceleration is ascribed to a force, the word kinetics is never mentioned. However, clear exceptions exist. Prominent examples include the Feynman Lectures on Physics, List of Fundamental Dynamics Principles, Newton's Laws of Motion, Inertia, Acceleration, Momentum, Reaction, Newton's Law of Universal Gravitation, Special Theory of Relativity, Axioms and Mathematical Treatments, Variational Principles and Lagrange's Equations, Hamilton's Equations, Canonical Transformations, Hamilton-Jacobi Theory, Related Engineering Branches, Particle Dynamics, Rigid Body Dynamics, Deformation Mechanics, Fluid Dynamics, Hydrodynamics, Gas Dynamics, Aerodynamics. Related subjects: statics,